To be SSH configuration intermediate level. So target audience would be people who have already executed an SSH command at one point in their developer or administrative lifetime, but have not delved deeper into the possibilities of SSH. So that's the target audience I'm trying to reach. If you already know more about the SSH config file, of course you're free to stay. Maybe there's a little nugget of knowledge that you haven't seen yet or haven't heard yet, but otherwise you probably will be bored, just so that you're warned. So yes, the hashtag, if you want to tweet or toot or whatever, it would be MCH 2022. And the slides will be available later on my website as well as in the Fahrplan, or the schedule, sorry, wrong event. I'm getting confused, I'm getting old. Right, before we start, just one word on command line syntax. So I have a lot of command line examples. I'm also doing some live demos, so just let me know if the font is too small or something, we can arrange something, and I can modify a few things. In order to make it more readable for you in the slides, I'm following the POSIX 2017 standard that a new line followed by a backslash shall be interpreted as a line continuation. To give you an example of that, so the command ls -a-l-t/temp could also be written as ls /new line -a /new line, etc., etc. The right-hand notation is just more readable on slides. You can just compress it into one line once you execute them. Right, so should we get into it? I think we should, because otherwise I'm running out of time, but I think we're good on that. That's your usual command, right? That's what you do if you do SSH on a machine. You have the command SSH, then you have the username, the @sign, and then the host that you want to reach. Once you enter that, whoops, not yet. Once you enter that, the server prompts you for the password, or even wants to verify the fingerprint of the server, and then asks you for the password. And if you then you do your work, you disconnect, later on you connect again, the server again asks for your password, you type this in over and over again. It's a little bit boring. If you're using STP, for example, to copy files, again, you have to execute SCP, username @hostname, then it asks for the password, and that's rather boring and repetitive. So let's see if we can do something about that. And I mean, this is, of course, the easy example. It could be a lot worse. If you have a system administrator who's heavily into H.P. Lovecraft-inspired server names, you get server names like these, and I think you don't want to type this more than once, right? I mean, that's just calling for problems. Fortunately, this is, by the way, the god of Zykranos, and is one of the greater old ones, in case you wonder. The thing, or the SSH feature that we are going to use, and which I will spend a lot of time on, is called SSH config. If you do a man5 SSH config, this is the information you will get. I mean, this is a lot more condensed than the man page. Basically, you can configure your SSH command, of course, through the command line options, username @host, and a few other commands and parameters. You can use a user configuration file. So this is a configuration that is applicable for each user. Each user can have his or her own config file. And of course, as a system administrator, you can also provide a system-wide configuration file for the SSH client. In this talk, I'm going to focus on the user configuration file, which is hosted in the user's homepage, which is symbolized by the tilde, and it's in the hidden directory called .ssh. and it's called config, surprisingly. Yeah. What can we do in that config file? Well, for one thing, we can define hostname aliases. So in case of the name of an elder god or something like that, you can just define the host demo and then specify one or more host names this applies to. Oh, the other way, no, sorry, the other way around. So you have one host name, your target, the server you want to reach is ssh-server.example.com, and with the host statement, you can give it one or more aliases, which is useful, which cuts down on the characters you have to type at the command line quite heavily. And you can not only have one alias for the same host name, but you can have several aliases for the same host name. So you can have demo, D1, or Popocatépetl, if that's more your thing to type. And so instead of ssh-server.example.com, I just type sshd1, and that cuts down tremendously on the number of characters I have to type to reach that server. Furthermore, the host name also has a nice feature to use a wildcard to support grouping similar host names. So if I have SMTP, IMAP, and www host names that are all connecting to the same or resolved to the same machine, I could use the %h feature to use the alias as the host name in the fully qualified domain name of the host name parameter. Right, so that already, so instead of ssh-server.example.com, we can just type ssh demo. So that's one thing we can cut down on typing. The other thing we can cut down on typing is, of course, the username. So I still have to type SSH username at host or at alias. Fortunately, the config file also has a user directive. So I can specify a username I want to use for that particular host or alias, which cuts down on the amount of type tremendously. So compare these two statements. The first one is the one I showed you at the beginning. It's SSH username at hostname, and now I just have to type SSH demo, and everything I specified in my config file is therefore applied, and I don't have to type it myself. So this is all sounds good, but let me show you how this actually works. So I am on my server, on my client, and I want to configure my SSH config. So I start my preferred editor, and I'm going to my, let's see if I can type while everyone is watching, and there will be a config file. So I'm using an editor, not an operating system like Emacs, and this is what we just talked about. I have my target server, which has the host name of ssh-server.example.com, and I define two aliases here. One is demo, the second one is bastion, which I will need in a later example. And I specify my username for this setup, which is, in this case, ladder. And if everything works as I expect, I should now be able to do a SSH demo. And I'm connected to the server, and asks me for my password, and I'm connected to my server. So that would be, as I said before, tremendous cut down on the number of characters that we have to type. And as we are all system admins or developers, we are all lazy. We want to cut down on the stuff we actually have to do. We much more prefer to wait for the compiler to compile or to the file transfer to complete. Right. So as you noticed, this cuts down on the connectivity, but the server is still asking for a password. So how can we fix this? Well, there's something called SSH public key authentication. So that helps us. It uses basically the public-private key setup that we already know from TLS or other protocols, to use keys to authenticate against the SSH server, so I don't have to provide my password every time I want to connect to a server. Additionally, the SSH public key authentication improves security considerably, and also offers additional usability benefits like single sign-on across multiple SSH servers. And another neat feature I will show you in a little bit once we got this all set up. The one thing you have to remember for asymmetric cryptography, you probably know, but I want to emphasize this as I'm targeting maybe new developers or new system administrators, is there are two keys in play with asymmetric cryptography. There's a public key and there's a private key. The public key you can share with everyone. That's sharing is caring. Share your public key as much as you like. There's no problem with that. Put it on the server, post it on your website, send it through fax if you live in Germany. It's fine. On the other hand, the private key is something you keep to yourself. That should reside on your laptop, that should reside on your PC, and you should not hand that out. You should not put it in a Git repository, you should not put it on a cloud store. This is your private key and your private key only, and it should not be shared. If it happens, create a new one. My preview just went out. But okay, this one is working. Okay, no worries. All right, so basically what it does is the server and the client exchange a few messages, encrypting with the public key. So as a user, if you want to use private public key cryptography to log into an SSH server, you have to copy. One time you have to copy your public key to the server, so the server knows your public key. Once the server knows your public key, it can then send you, during the initiation of the connection, it will send the client a message encrypted with the public key of the client. The client can therefore decrypt that message with its private key, will encrypt an answer that also includes the message that the server sent with the private key of the client, and with the public key of the server, sends it back to the server, and the server decrypts it with its private key and checks that the messages were transmitted without change, therefore authenticating the client and allowing you to start to work. This is all working under the hood. It's using the Diffie-Hellman key exchange, so we know that it is secure and safe and it's properly implemented, at least in the more used distributions. So this is it's really simple, and it's a few commands, and you're on the way to go. So what do you need for public-private key cryptography or public-private key SSH authentication? You need a key, of course. You need two keys, a public key and a private key. The command to create that would be, come on, SSH keygen. So SSH keygen has quite a lot of parameters. These are the ones I regularly use and I usually recommend. So you have the command SSH keygen or key generator, and then you're specifying the type of public-private key cryptography that you want to use. In this case, I'm using curve 25519. Oh, it's raining, nice. It's 25519, which is an elliptic curve, which creates highly secure but very small keys. So this is really a nice feature if you're working with embedded systems and stuff like that. They are usually happily using elliptic curve cryptography. Of course, you could also still use RSA keys. They're just 40,000 bit length is fine and works as well, just a little bit bigger. And all modern systems usually support ED25519, so it's good. The A option is a pet peeve of mine. You can leave it out if you want to. That's basically defining the number of rounds that the algorithm computes when it creates the key. the higher number will result in a slower passphrase verification process, but it will increase your resistance to brute force password cracking of the private key in case it gets stolen. So that's basically a security feature in case your private key gets accidentally uploaded to GitHub or something like that. I think we have to turn up the volume because the rain is getting really loud. Thank you. The -F option is there to specify the file name where you want to save your private key and your public key. You specify a file name and the extensions will be added as needed. In this case, and I usually do that, I save it into my home directory, into the SSH directory, and I named it in this case demo.ed25519 because I do it. What I would highly recommend is to always, if you're using SSH keygen, to always add a comment with the -C option. Because if you have multiple keys, figuring out which key belongs to what and which key applies to which server or to which customer can get quite tedious. So having a comment reminding me, oh, I created this for MCH, okay, I can delete it, or oh, I still need it, or whatever. So having a comment in the key is always a very nice feature. So before we look at it, let's do this. Again, I have my command line and I create a key. As I said before, I have it here in the per line syntax, and here in the command line, I'm just using one line. You should always have a passphrase on your key. And of course, if you type in public, you never type the password correctly again twice. Let's see. Okay, 3 times the charm. Not talking and typing at the same time helps. And once the computer has finished its computations, you get an output like this. And let me show you a little bit more about that output. So that's the output, basically. And the first thing it's telling you, okay, I'm creating an ED25519 key pair, and it asks you for a passphrase. As said before, you should always have a passphrase. There should no private key without a passphrase, except for some very special circumstances where you should really know what you're doing. As we're talking about intermediate level setups, you should always have a passphrase for an SSH key. Once SSH keygen has finished its work, it also tells us it generated 2 files. The demo ed25519 file, that's your private key. If it has the extension .pub, that's your public key. Please don't mix them up. Please don't upload the private key to GitHub or GitLab or another of these sites. These files are actually text files, so you can take a look at them. So let's take a look at the public file. The public file begins with the information, okay, which encryption algorithm did we, which asymmetric option did we choose? We chose ED25519. Then there's the key information. Again, this is the public key. You can share this freely. And the nice thing about it is, at the end of the public key, the comment gets added. So if you add this to a server, the administrator also has an option to see, okay, whose key is this? Why is it there? So choose a proper comment, and it will your life and the life of your administrator a lot easier. I'm doing this here as it's a demo setup and I scratch it, but you should never do this in public. You can also, of course, take a look at the private key, which basically looks like this and resides on your client. Again, anyone with a copy of the public key can encrypt data for you, but only you, if you own the private key, can decrypt. So this Authorized keys for you are really your thing, and you should handle your private key very carefully. On the other hand, the public-private key key pair is free. They're free to generate. You've seen this takes literally a few seconds to generate once you have the command down. So please, please, please create more than one key. If you connect to different servers, if you connect to different customer servers, for example, have at least a key pair for each customer. If you're connecting to GitHub and to GitLab, please create a public-private key pair for GitHub and a separate one for GitLab. Because what happens if you lose one of these keys? If you only have one public-private key pair, all of the systems are compromised. If you have a public-private key pair for each customer or for each service that you're going to use, or for each server even that you're going to connect to, only that server is affected, and only you have to make the system administrator of that server aware. There's nothing for. I'm doing a lot of consulting work. There's nothing more embarrassing than to tell the customer, look, I lost the key pair for access to another customer's servers, but your servers are also affected because I used the same public-private key pair. That's not a nice thing to communicate. So they are free. It doesn't cost much. Create one for each server of each customer or each service you connect to. Sorry. So. That was the creation of the key pair. Just give me a second. And I already mentioned that that in order for this to work, we have to copy the public key and only the public key to the server we want to connect to. So there are several options to do that. You can copy it through the clipboard, you can transfer it as a file, and that's the nice thing, there's also a command for it. So there's SSH copy ID, which will allow you to copy the public key to a server that you want that public key copied to. Again, it's the same syntax as for all other services, and I missed the server name there. I will show you in the demo how this actually looks. And where do you copy this? So SSH copy ID basically takes care of everything. You just tell it, take this public key file, copy it to that server. You don't have to think about directories, file names, etc. If you want to do it manually, you need to copy the demo.ed25519.pub public key file to the server, into your home directory, into the .ssh directory, and into the authorized keys file. This authorized keys file, if it does not exist, needs special permissions. So if that file does not have 644 file permissions, the whole thing will not work. Again, SSH copy ID will take care of that for you and will create that for you, so you don't have to think about that. That's why I'd like to prefer the SSH copy ID command over the manual creation of that file. And also in newer versions, so if you're on Debian old stable, probably not, but in newer releases, the SSH copy ID file also makes sure that you're not copying the private key to the server, so it's a nice security feature as well. Right, so let's see if we can do that in my demo environment as well. So again, the command here, is this readable or should I make it bigger? It's good? Okay, great. The command is again SSH copy ID -i and the ID file, the public ID file you want to copy, and then the target in our system demo. The nice thing about having a config file that we created earlier is these aliases that we created there apply to all SSH-related commands. We can use the same alias for SCP, for SSH copy ID, and all the other stuff. So it's really nice. So in this case, demo is our alias for Leider at ssh-example.com. And it says, okay, Yep, I found the public key file. I'm attempting to log in. Of course, the public key is not uploaded yet, so it still asks me for the password. And remember, please enter Lyra at sshserver.example.com's password. I enter that, and it tells me, hooray, successfully, I connected to the server, I uploaded the public key to the server, and let's try again to log in. So, SSH demo. Why is it asking for the password? It shouldn't ask for the password. Ah, yes, of course, because I'm stupid. We still need to tell SSH that it should use the ID file to the private key to connect to the server. So let's try again, specifying the identity file that we want to use. Well, come on. I'm on the server. Thank you, that's a usual mistake I make. Yes, correct. Thanks for staying with me, awesome. So, third attempt, third time's the charm. Yes, and now it's not asking, and if you look closely, it's not asking for the user's password, it's asking for the passphrase of the private key, which is a different thing, right? Yeah, and it's connected to the server. Hooray, thankfully. So we now basically have established that we can, let me just log out here again, because otherwise, that wasn't good. That was one logout too many. Yeah, all good. So that's basically, we were basically verifying that the public-private key authentication was successful. Of course, the next thing would be to modify our configuration file so that we don't have to pass the identity file, the private key, as a parameter while calling the SSH command. So let's do that quickly, and that would be these two lines. .ssh config. Let's do it properly. And we just add 2 additional lines. The preferred authentication's public key, it's basically just speeding up things. So I'm telling the SSH client, don't even bother with username, password, just try public key authentication and nothing else. And with the line identity file, I specify the file that I want to use for client authentication, public-private key authentication. And if I save that, and now what I had in mind should work. So we have the username, the target host, and the identity file that we want to use in the config. And again, it's asking for the passphrase, and I'm able to log in. Yes, hooray. Awesome. It's nice when something works. Again, preferred authentication's public key to speed things up, and the identity file to use in that case. And again, public-private keys are free. They are easy to generate. Use a different identity file for each service or for each server that you want to connect to. And we said before, SSH demo, and we don't have to type that much, which is awesome. Hooray! Next question that usually comes up when I give this talk is, yeah, but we haven't improved anything. We still have to type in something. We don't care if it's the username or the password for the user or the passphrase for the private key. Yes, that's true. But there is a solution for that. So we are now at the stage where we have public-private key authentication to the server enabled, which is, of course, more secure, etc., etc. But how can we work around the issue that I still have to enter a passphrase for that key. And again, it's the passphrase for the key, not the user's password. Well, there's something called SSH agent. And SSH agent is a small program that runs on your machine, creates a socket, and waits for SSH to request the private key unencrypted to do its work. This is very, very convenient. So you start SSH agent, you do an SSH add to add that key to the agent. The agent keeps that key in memory and makes it available to the SSH client in case you want to connect to a server. So you only have to present the passphrase once, and after that, the second, third, fifth time, it does not ask for the passphrase of the private key again. That's the hardcore low-level command line only option. If you're using a graphical user interface, if you're using GNOME Keyring or K-Wallet, or if you're using a Mac, the SSH agent functionality is usually incorporated into these tools. So if you're using the GNOME desktop, usually the GNOME Keyring decrypts or opens has all your SSH private keys unlocked. That was the word I was looking for. Unlocked as soon as you log into your operating system's desktop. On Mac OS, that's the same for the keyring. You log into the Mac OS, and all the SSH client certificates are unlocked once you're unlocked into the system. If you have high secure requirements, if you have requirements for a high secure environment, you want to rethink this, and maybe you will have to enter the passphrase every time. And in my advanced talk, we can also take a look at storing the passphrase on a FIDO2 device, or use FIDO2 and other stuff to do two-factor authentication. Too many tools in there. But for now, let's take a look at SSH agent. Again, if you're using a graphical user interface on your laptop, and of course 2022 is the year of Linux on the desktop, so let's do that. Yes, one more thing on the SSH agent. You can, if you add a key to that SSH agent runs in the background and waits for a connect. And if you add your private key to SSH agent, you can give an option of -C, which will instruct SSH agent to prompt you, do you really want to use that key now? This is their stopgap to make it a little bit more secure. But again, if you have high security requirements, you might want to rethink the usage of SSH agent. So again, SSH agent is running in the background, and I need to add my private key identities to that agent. So there's a command for it called SSH add. If you only give it the file name, it will add that key to the SSH agent keyring. -D removes it, and as I said before, -C will prompt you for usage every time you want to use it. So to connect without a passphrase, we're almost there. We only have to add our private key to the SSH agent. I think that's good. Oh, I really have to type this. Oh my God. SSH add. Let's do it again. SSH add -E. The choice of switching between German and American keyboards. Yeah. And so basically, I'm telling SSH add the file demo.ed25519, which is my private key, to the SSH agent. Yes, hooray! Thank you, demo gods. Yeah, I know what the problem is. Let me just, because I exited out of that session, so I lost all the, let me first switch to the proper keyboard, and then it's easier for me to type. Yeah. And I wanted to hide this from you, but apparently that was unsuccessful. Right, so let's try again. SSH add. Yes, and it's asking me for my passphrase. Finally, it works. Every command with SSH requires you the -i if you specify the ID file, the private key, except for SSH add. And now I get the message identity added. So SSH agent now knows about this private key, and I already committed my passphrase. So the unlocked private key is now stored in the SSH agent memory. And if I do an SSH demo, we should see no password. Yay! One more thing. The nice thing about SSH is once you have this configured and running, what you, for example, could do is an SCP. So SCP is copy, right? It's file copy. It's like a local copy, but over the net. And I want to copy something from the server to my local machine. So I give it the alias. Again, the config file works here as well. And then say, okay, I want something from etc. And now I do a double tap on the tab key, the tab letter key. And I get remote tab completion, which is very nice and very convenient, because I can't remember the paths and the file names. I'm old, I don't want to think about those. So once you have public-private key authentication set up, you will get remote auto-completion, which in my personal opinion, is worth the hassle to set it up once. It's really cool. Right. So that was one of the benefits of having public-private key authentication. Yeah, I skipped that. One thing I wanted to mention, need to speed up a little bit. One thing I wanted to mention is this is also available on Windows. So if you're using PuTTY, you have basically 3 commands. You have PuTTY-gen, which is your keygen for Windows. You have your PuTTY agent, which is your SSH agent, and you have PuTTY, which is your SSH client. And with PuTTY-gen, what you have to keep in mind is there is a button there which says Save Public Key. But that is saved in a proprietary format. What you need in order to get public-private key going is actually the public key text that is displayed in the bottom in the top of the PuTTY key generator. That's the thing you want on the server to actually work if you're connecting to an open SSH server. Other than that, it's completely the same. At the bottom, you can specify which key to generate, RSA, or in our case, 825519. And you will get a private key. You want to save the private key in this case. And if you start PuTTY agent, you can add keys here. Again, it's the same as in Linux, but you have fancy buttons and user interface for that. And within PuTTY, if you go to connections, SSH auth for authentication, so it's rather it's a very convoluted navigation. You can actually specify the private key you want to use, and then you get the same functionality, the same benefits as on Linux with if you have to use Windows because your customer only supports Windows as a desktop. There's also more. There's more SSH config magic. What you have to keep in mind for SSH config files is for each parameter, the first value obtained will be used. So you want the more specific stuff on top, and you want the more general stuff at the bottom of the file. Yeah, because it's not going to take the last thing, it's going to take the first thing it finds. If you specify something else below, SSH doesn't care about that. So you want host-specific stuff at the top, general defaults at the end. How does that look like? So in this example, if I want to connect to a server like web.prod.example.com, it will take my prod ID private file, the last one at the bottom. But for one server, which is unicorn.prod.example.com, it will not take the prod ID at the bottom because I have a more specific thing on above that, and it will take the pink fluffy ID as the private key for that particular server. And for all the servers that are within the test.example.com domain, it takes the test ID private file. So this is something you can easily set up. And again, more general stuff at the bottom, more specific stuff at the top. To give you another example, this is again something from my demo here. You will have we have our demo host entry with the host name and username and preferred authentication. Then we could have several more host entries, and then we have a catch-all that is host asterisk, and that's basically setting additional stuff. What I usually want to have is compression, yes, because I have to connect to servers in the US and Asia, so compression does help. And the identities only is also a nice thing, because otherwise SSH will just try every identity file it finds to connect to that server, and you will get errors. And with identities only, it will only use the identity files specified in the host entry to use to connect to that thing. I do have to speed up a little bit. What you could also do is, within the .ssh directory, you could have conf.d directory, where you can have multiple files, so you can separate the configuration out for each customer or each server you want to configure, and it pulls those in alphabetic order. Last thing I want to touch on, that's why I'm skipping this a little bit, is Bastion or jump hosts. What do I mean by that? You have your client, you have something called a jump host or a Bastion host that is connected to the internet, and you have the actual server where you want to work on, or where you want to have to do some work on, that is not reachable from the internet directly or from your client directly. So you have to go through that jump or Bastion host. So what you usually do is you SSH into the Bastion host, then you're logged in at the Bastion host, and from there SSH to the target host. So basically what you do is SSH demo or Bastion, let's keep it with demo, right? And then you do, where is it? Yeah, and then you SSH further on, and then you SSH further on to, and I'm using the same username here. I like to explicitly specify my usernames. Target.local, which is a machine I can't reach from my client. Target, of course. Tommy. And I'm on my internal server. So that's what you usually do, and it's quite cumbersome because you have to log in and log in and log in and log in. Server client, here I'm correct. So what you can actually do is you can specify something called a jump host. So with the option -G, you can define a jump host or a jump host alias that you want to use to get to the target machine. So I want to connect to target.local, but I'm telling SSH to use Bastion as an intermediate, as a jump host. Of course, everything that is specific, that you can specify on the command line, you can also put into the config file. So in this case, I have my specification of my demo host alias, and I have an alias for internal. And if I and in there, in the host internal, I can specify proxy jump and the alias, and with that it knows, okay, if I just enter SSH internal, it will automatically use the Bastion host to connect to that machine. So, do I have this prepared? No, that's bad. Just give me a sec. There we are. Yeah. Yeah. So on my client.ssh config, I'll add this, and if I go there, so I now enter the Bastion host. So if I do an SSH target.local, no, just local. I created an alias. Internal, thank you. I created an alias called internal, and it tells me, yeah, you're connecting for the first time. Yeah, that's fine. And I haven't configured public-private key authentication for that as well. The nice thing, if you configure it that way, is that the first connection gets tunneled through the SSH. So you connect to the Bastion host, and then you connect through that connection to the internal server. So if you pass on the identity file, the SSH agent can talk directly to your internal servers. You don't need agent forwarding and everything else, which is a lot more secure than having SSH agent forwarding running on that Bastion host. But of course, it also works with password authentication. Again, if you have an older SSH configuration, you can also fall back to the proxy command. I'm just leaving this here in the slides as a reference. Please use the jump host directive, use the -J option. Do not use -A or agent forwarding anymore. It's insecure. You shouldn't use it. It's outdated. The jump host is the better option. I will skip that. You can read on that if you want to. And that concludes my short and rather long talk. Thank you very much for your participation, and have a great day.
We've got time for one question.
Yeah, let's do one.
Thank you. Yeah, actually, yeah, the demo cards were not kind, but actually, it helps to see that you make mistakes. We all make mistakes, and then we correct them, and we learn. We've probably got time for one or two questions, if anyone has one. Oh, we've got one here.
All right.
Good morning. We jumped in a little late, but is it possible with the jump host to also forward local and remote tunnel sessions?
Yes.
Okay.
Yes,
you can configure it the same way as normally.
Yeah, as usual.
Okay, perfect.
That would be my advanced talk. Maybe next year or next time. Right. I'm still around. I'm helping with teardowns. If you have any questions, feel free to approach me, and I will be around. Thanks very much.
Thank you very much indeed.